Unit 6, lesson 6, so case analysis. Essentially what we're doing here is you're kind of breaking the graphs up into the positive pieces and the negative pieces. And so, like for example, if it says I want to know when x squared minus 2x plus 8 is less than 0, I said it out loud, but the focus is less than 0 means what? Below. I want to know when this graph is negative. And then you write an inequality that tells when the graph is negative. So that's what we're doing today, is it's telling us where it wants our graph, and then we're writing an inequality that represents that section. So where's the positive piece? Where's the negative piece? Okay? And so that's what we're thinking about. So here's what we're talking about. A quadratic inequality in one variable takes one of the following forms. Your general form less than 0, less than equal to 0, greater than 0, greater than equal to 0. Okay, so solving quadratic inequalities by graphing. So you have an x squared plus 2x minus 8 greater than 0, and x squared plus 2x minus 8 less than 0 are quadratic inequalities whose solutions can be determined from the graph of the associated function. Okay, so we're using the graph. We're just graphing this is all it's saying. The graph of this, so if you just factored that, you'd figure out the x-intercepts are -4 and +2. So the graph crosses through -4 and +2. Now, this is what we're doing today. All that stuff you know how to do. It says the x-coordinates of the point on the graph which the above x-axis is a solution to this inequality. So what that means, I know it's choppy, what x values cause this graph to be positive? That's what it's saying. What x values cause this graph to be positive? And so then you need to be like, oh, that would be this piece and this piece. No, because that's always going to be the case, right? Because that means it's positive. You're talking about the y's. We're talking about the x's. So what do we want our x to be? We want our x to be less than -4, greater than 2. What's that? It is, but what's the zeros, right? So it's not factored wrong. The solutions are the opposites. Yeah. Yep. Now again, you can check this every time. A number less than -4, -5. If I plug -5 into this, it should be a positive value. -5 squared, 25. 2 times -5 is -10 minus 8. 25 minus 18 is 7. That's why this value right here is 7. So that means the positive spot. Okay? And so then when you want less than, the less than would be in between those two zeros. So we'd want x greater than -4 and x less than 2. And that would be this section, right? Right there. What's that? We're not shading, no. That's the thing is, so shading is 2 variables. That's why they say at the beginning when there's one variable. See how there's just an x? There's x and y, then you're finding points that work. Right. 2 variables is when we want to shade. Okay. Any other questions on that? Nah. Yeah.
So that bottom one.
Mm-hmm. Right. So this means x greater than -4, greater than, less than 2. So between, that's putting you between here. Okay. Anything else? Okay, we'll do the next one. Okay, so then complete the following on the graph below. So we already did this. The solution to the inequality of x squared greater than is, we just wrote them, so this is just rewriting what we wrote. It was x less than -4, x greater than 2, and then x is between -4 and 2. And these are the number line solutions. Okay, we'll talk about that too when you get done writing that in. So no, because what they gave us wasn't, so we don't have an equal to. Okay. Right. If it said equal to, but they have to tell us which they want. So if they tell us, if they say, the equation is less than or equal to 0, then we include it. And we only want that piece, right? We're writing both pieces right now just to see if they are, but we're only going to have to do one. Okay. So here's how you write the solution on a number line. So here's your zeros. You just plot your zeros. Open dot on both these because they're just less thans and greater thans. This is the first one, so this is when it was positive. And this is the second one between, right, when it was negative. So that's how you do it on a number line. All right. So let's look at this one. Use a graph of the function 12 plus 4x minus x squared to solve the inequality. Okay, show the solution on a number line and state the solution to the inequality. Okay, so let's see here. What does this look like? I have to do that backwards factoring. I don't like that, but that's okay. It's going to be 6 and 2. It's going to be 6, 2. I got one positive x and one negative x. I want this to be the positive x and that to be the negative x. So that's what I have. Yeah, it's still a negative x squared. I don't like that. What you could is you could pull a negative out. But then, yeah, you could pull a negative out. That could still work. Okay, but I see here my solutions are at 6 and negative 2. So here they are. It goes through 12. So, and it's a downward. So it's looking like this. Something like that. So this is what I was talking to Parker about there. This one wants strictly the what? Greater than equal to. Okay? So it wants greater than equal to, so it wants this piece. That piece is, right, between negative 2 and 6. So your number line would look like this. Negative 2. Right, and so you would go solid between. So notice this one's greater than, and it's between. The last one's greater than, it's the outside. What caused that to change? Because it's flipped, the parabola is flipped, exactly. Okay, so don't sit there and say everything greater than is between or everything less than is outside. That's not the case. I was just saying that don't just think that everything that's greater than is between. That's not true. Because it depends if the graph flips or not. So I'm just trying to make sure you don't say, oh, every greater than is this, because people like to do that. Okay? This one changed because our last question, when we did greater than, it was the outside. Right? This time it's the inside because the parabola was flipped.
Oh, okay. So that's what I meant. Like, if you draw it on the inside, it
Right. Say the solution to the inequality. So we've already done that, or we haven't done it yet. The solution is x greater than or equal to negative 2, less than or equal to 6. That's your solution. Okay, and then there's a way you can do it without looking at the graph that we're going to talk about a little bit, the little bit algebraic way. Okay. Okay, so Colin wondered if he could solve the inequality x squared plus 2x minus 8 greater than 0 from class example 1 without drawing the graph. So what he did is that he factored it, and then he broke it up into two pieces, and he got the solutions of x greater than negative 4 and x greater than 2. And it says since x has to be both greater than negative 4 and greater than 2, he concluded that the solution was greater than 2. He took the one that worked for both. That's not necessarily the case. Okay, and so we're going to try to figure out if you guys can tell me maybe what's wrong with this. And so let's just start basic here. Okay, this is right. He broke them down to the factors. Okay, he broke them down to the factors. So you need to see we have two things multiplying. We have two things being multiplied that need to be what type of number? Which is positive, right? So what this means is two things being multiplied has to be positive. So now I'm going to ask you, when you're multiplying numbers, what are ways to multiply two things to get a positive number? Two negatives, two positives, right? And so we have to see how he did this. He did the two positive solving, but he didn't do the two negative. Let me say that again. He did the two positive solving, but he didn't do the two negatives. You have to do both things that could get you a positive. So the other one he has to do is he has to do negative x minus 4 and he has to do negative x plus 2 and solve for those.
It's like piecewise. Wait, so you have to switch all the signs?
Yeah, it's kind of like piecewise. Right, it's exactly what we did for our piecewise where we had to like do the negative piece, yep. So solve, so add the 4, and you're going to see what's going to happen. Negative x greater than 4, divide by negative, we have to flip the sign, so now it's less than negative 4. This one here, minus the 2. Negative x greater than negative 2, so x less than 2. And so what we have to do is, we know the parabolas, like for example, parabolas, guys, every time, they're going to, if they have intercepts, which these do, hurry up, okay? Every time that these things are, you have zeros, that means it has a positive and a negative piece. Let me say that one more time. Every time that you have a parabola that has zeros, you have positive piece and negative piece. So that means you're going to have, no matter what, you're going to have an outside and an inside, even if you flip it. The outside and the inside, in terms of negative and positive. So what I'm saying is, your answer is either going to be between or outside, no matter what, if you have zeros. So his solution doesn't make any sense. He has 2 greater thans. So he has greater than here, greater than here. So that means his parabola does this and doesn't come back, right? That's silly. Okay? So what you have to do is, you have to figure out, okay, this is a positive parabola. So we should understand positive parabola dips in something like this. If we want the positive piece, we want the outside or the inside? Positive piece. Positives are outside, right? Right. So what he got was, this is correct. That's the correct one. It's a combo of the 2 solving. So this one doesn't work, and this one doesn't work. Yeah, so it's tricky. Let's try one. We could test a point if we know where they work.
Wait, so if you did it that way, like flip it, or like just do both?
Right. So when he solved, the point is that when you solved, he got the positive piece. And so here's what's happening picture-wise. I'll show you. Okay, so let's go back up here. All right. So when he did these 2 positive pieces, and notice they're both greater than, what he's doing is he's finding the piece over here, that one only, the greater than one.
Oh.
Because that's the positive 0, right? These are both saying positive 0. So what we have to do is we have to also think about the negative 0. So we switch these, negative 4 greater than 0, and we solve. And what happens is we get the other piece. We get this piece. And what we have to know is there's false answers. That's the part that's confusing. Because when we switch it, we get the opposite. But we have to know we want less than negative 4, greater than 2. And so the case analysis is what it does is it helps you kind of decipher which way to go, what to expect. So I think if you wanted to do an all the time thing, if you have zeros and you have a positive parabola, your positive pieces are always outside. If you have a negative parabola, it's always going to be inside for the positives. Yeah, so it just flips. So those are things you can think about too.
With ones like that, you could just, instead of like having to factor it out, you could just switch the sign
Right.
instead of having to like do it.
Right, and that's where I was saying you don't have to do the complete process. Like if you understand the graph, then you can kind of do that on your own. That's the algebraic way of demonstrating it. So that's what I kind of meant, that this whole process you can probably get by without knowing it completely, but I still like to show it to you. Okay, so here's this one. Factor. Okay, want less than or equal to 0. Is this parabola positive or negative? Positive, so we know this parabola is going to be doing something like this. We want the between. It told me. Yeah, it's right there.
So when it's less than or equal to 0 is positive and when it's greater than?
Say it one more time.
When it's less than 0 is positive, if it's greater than
No, less than 0 is negative. It's a positive parabola, I said. This parabola is positive, so it's going up.
Okay.
Yeah, sorry if that was confusing.
Which one would you use the negative x with the negative zeros to solve?
So how do we get negatives? We get negatives by plus times minus and minus times plus. And so that's how you solve algebraically for this one. That's how it's different. The one was before was positive, positive, negative, negative. Now this has to be different. So what you're going to do is you're going to go opposite. So I'll take this one normal, positive. Okay, and I do, whoops, it's less than. X minus 5 less than or equal to 0. And then I do the opposite of the second one. Okay, and then I do this one opposite. And I do this one normal. Yeah, just quickly, right? Yeah, so this one's x is less than or equal to 5. Yeah, we didn't multiply. Yeah, it's okay. Okay, then negative x less than or equal to 4. X is greater than or equal to negative 4, so we'll flip there, though. So there's your first two. So one's less than 5. One's greater than negative 4. That's actually probably going to work. We'll look at the next one, though. This one's okay. Greater than 5, less than negative 4. So you should read this. When you read this, this is outside. This one's inside. So which one do we want? We want the inside. So this one's our solution. Right, less than 0, and it's a positive parabola, so that's inside.
So if it was greater than, we would say we would want to solve for the outside.
Right, we want the outside. So if it was a greater than, now here's the thing, if it was greater than, we do the same exact thing we just did. But then when we go down here, we'd say, oh, we want this set. So it's kind of it's difficult in this is the negative, negative, and the positive, positive gives you one of each. So you have to use both of those. These ones give you one answer, one wrong answer.
So
What's
Yep.
the difference between the positive, positive, and the negative, negative, and the positive, negative, negative, positive?
Okay, so the positive, positive, negative, negative was for greater than or equal to 0. Because those get you positive numbers.
Oh, okay.
Yeah. No, I knew what he meant, though. He says, why do we switch?
Yeah.
We switch to these ones because these are negative outputs, and this says we want negative.
Okay.
Yeah. Okay? All right. So, let's see here. So then when quadratic quality is greater than 0, this is called case analysis. This we're talking about. You have case 1, both factors are positive. Case 2, both factors are negative. We just did that. For quadratic is less than 0, first factor is positive, second factor is negative. First factor is negative, second factor is positive. Note that when solving a particular case, they may not have a solution. Okay, so there cannot be a solution. That can happen. Okay, okay. So last one here. Let's see. Let's try this one. So we got greater than or equal to 0. So that means we're looking at. So then to Lucas's point, positive, positive, or negative, negative. That's our case analysis here. So we have to do our decomp here kind of backwards. But negative 3 times 5 is negative 15. Factors of negative 15 that get you negative 14 is negative 15 and 1. So you're going to go 5 minus 15x plus x minus 3x squared. Group. Pull the 5 out. 1 minus 3x. Pull an x out. 1 minus 3x. So your factored form is okay. So we should be thinking, it's over here on the side, it's a up or down parabola. Down through negative 5 and negative 1/3. So it looks something like that. So we want what? Positive. So what are we looking for? Middle, in between, right. So let's do it here. So we're going to go, let's do positive, positive first. 5 plus x is greater than or equal to 0. 1 minus 3x is greater than or equal to 0. So that's going to be x greater than or equal to negative 5. That's going to be negative 3x greater than or equal to negative 1. X greater than or equal, oh, flip. Positive, because it's negative, negative, yeah. Less than 1/3. So greater than negative 5 and less than 1/3. That one works.
Could you solve the 1 minus 3x by adding 3x to the percent?
So then why would you not do
Dividing by 3?
Yeah, so
why
let's,
would you not do the opposite?
yeah, that's sometimes that happens where it's going to work for the whole one. Let's look at the other one real quick, and then I'll take your question, Parker. Negative 5 minus x greater than or equal to 0. And let's look at, so that's going to be add x. I'm just going to add x. This will be x less than or equal to negative 5. Yeah, so this one's going to give us the opposite. That does happen sometimes with these ones. Negative, add 3x. So that's x less than 1/3. Did I get x less than 1/3? If I add that over, yeah, 1/3. Oh, I didn't flip it. That's stupid. Okay, I'm doing the same problem. So it's going to be, sorry, if we're doing the opposite of 1 minus 3x, it'd be negative 1 plus 3x is greater than or equal to 0. So then I get 3x, 1, x greater than or equal to 1/3. So see, this one's greater than and less than, so that's the outside piece. So those ones we don't want. So essentially with the 4, you're mix matching, trying to find the outside pieces versus the inside pieces. It does flip. The negative sign, so it does that. So there's not really, it's more just knowing what you're looking for. Okay, so like when I saw greater than negative 5, I knew I wanted that because that's going to be, that's inside. It's going greater than negative 5, that's in my parabola. Less than 1/3. Now those are coming together. This is what I want here, so that's good. Okay, so stop there.